Hello everyone, welcome to this next video on complex analysis. This video is again taken from the paper of GATE 2004 and this is of 2 marks. The question says if we are given two functions f is equal to u plus iota v and another function is g is equal to v plus iota u, they are two non-zero and analytic functions. They are given to be analytic as well as non-zero where in this particular domain. So this is a inside of unit circle, right? Then they are asking which of these four is correct. So for that, our approach should be, we are given these two functions, f that is given to be u plus iota v and g that is given to be v plus iota u, and they both are given to be analytic. So now if they both are analytic, if we somehow know about know about these two functions, that means if we are able to calculate what is f or what is g, we can answer these questions which are based on the properties of this function f and the function g, right? So the only information we have is firstly they are non-zero, that means f is not equal to 0 and the function g is not equal to 0, and the other thing that is given to us is that this is an analytic. They both are in fact analytic. So if a complex function is analytic, that means it will satisfy the Cauchy-Riemann equations. And what are these conditions? So the conditions if we apply on f, so that means we would have u of x is equal to v of y, right? This is the real part and this is the imaginary part. And the second condition we would have is u of y is equal to minus v of x, where these subscripts that represent the partial derivative of these functions with respect to the subscript x or y, right? So this is our equation number 1 and this is our equation number 2. Now we'll apply the same result on g, that means we'll apply the Cauchy-Riemann equations on g. So now we would take the partial derivative of this real part with respect to x, so that should be equal to the partial derivative of this imaginary part with respect to y. Say this is our equation number 3, and similarly we have the partial derivative of the real part with respect to y, that should be equal to minus the partial derivative of u, the imaginary part, with respect to x. So call it as equation number 4. So now we can use equation number 1 and 4. So using this one and this equation, we would have ux is equal to vy, and we know further vy that is equal to minus ux. So in effect we would have ux is equal to minus ux, or in other words you can write 2ux is equal to 0, or simply u of x is equal to 0. So now if the derivative of some function is 0, that means the function itself should be a constant. Or because now the derivative of this function is basically a function of both x and y, and we are taking its partial derivative with respect to x. So now if its partial derivative with respect to x is 0, so that means you say u is constant in x, or you can say u is a function of some function of y only, right? Some function of y only. So this information we have about u. Now let us see what we can say about v. So for v, we can use equation 2 and equation 3. So from there we could write vx is equal to minus vx, or in other words you again have vx is equal to 0. So if vx is 0, again we can say by using this same thing, that means the partial derivative with respect to x of this function v, taking both the arguments x and y, this is equal to 0. So that means v should be a constant, v should be a constant in x. If it is a constant in x, that means it should also be some function of y. So similarly, if we calculate the partial, if we have just calculated that v is a constant in x and u is also constant in x, so, from these two terms, ux, seeing ux and vx. So now we can again use these equations to look at vy and similarly uy. So how we can calculate these two? Again, we can use equation 1 and 4, not 1 and 4, but here equation 2 and 3. So if we use equation 2 and 3, so from there uy is equal to minus vx, and we know what is vx? Vx is equal to uy. So using equation 3, we have u of y. So again we would have something like 2uy is equal to 0, and again uy is equal to 0. Now if the partial derivative of this function with respect to y is equal to 0, that means this function is also, so u is also constant in y. If now it is constant in x as well as constant in y, so that means u is basically a constant containing no terms of x and y. So from here we got this information, and similarly if we solve this using equation 1 and 4, so what would be vy? So if we look at our equations, so vy using equation 1 and 4, vy would be equal to ux, so it would be equal to ux, and from this equation 4, this ux is equal to minus vy, so this would be minus vy. So again we would have something like vy is equal to 0, so that means v should be a constant in y, so that means if it is a constant in x as well as in y, so it is overall a constant. If u is constant, v is constant, that means the function f defined by u plus iota v using this expression is also a constant. If this function, we got f to be constant. If this function is overall constant, so that means its derivative is equivalent to 0. So from here we saw that option 1 here appears to be the correct one. Why? Because we got u and v both to be constants, and if they both are constants, so that means f is also a constant. If f is a constant, that means its derivative comes out to be a number 0, and we cannot make any other we cannot remark anything about these two options from this information. So from here we conclude that option A is the correct option. So well, that is it for this video. Thank you for watching.